Hi, everybody.
Hi, folks.
Thanks for joining us. So,
Do you want to stand on the stage?
yeah,
Okay.
no, actually, we're about right like
It's
this.
perfect. I feel so tall. This is wonderful.
Cool. So I'm Damien Brady, Damo Visa on Twitter. I'm the DevOps part of this DevOps for data science stuff.
Excellent. And I am Paige Bailey, dynamic web page via the Twitters and pretty much everywhere else on the internet. And I am the data science-y part.
Yeah, and what we thought we'd do, rather than have us organized, prepared presentations and demos and things like that, is we kind of open this up to be a bit more of a discussion about DevOps and data science, which I think suits us both a little bit better.
Yeah, and to open it up to your questions as well.
Yeah.
So if you have anything that you've been struggling with or any questions about kind of the options for collaboration between the two different functions, feel free to ask. But do you want to get started?
Yeah, so the one slide I wanted to show you is this is Microsoft's definition of DevOps. No, that's the data science one. Oh, it changed. All right, well, let's do the data science one first.
Cool. So this page is intentionally left blank because I did not give Damien a data science slide.
If you've seen her schedule, that's okay.
But thank you. But so data science is really the it spans a lot of different areas. So you can do descriptive analysis, which is just looking at historic data and usually making dashboards. But the more interesting bit, the bit that I think we're all very excited about, is predictive modeling and using machine learning and especially deep learning in order to architect solutions and build predictive either classifiers or regression models for your software applications. So data science kind of encompasses being able to pull in data, get it into a state that it needs to be in to be ingested into a machine learning model, then to build that model, to retrain it, to change hyperparameters, and to monitor performance and accuracy, to deploy it, and then to make sure that once it's deployed, it's still doing what it's supposed to, so that your model is sustainable over time.
Yeah.
So that is all bits and pieces of data science.
Yeah. So the important part from a DevOps perspective is the last part of what you said there,
Yep.
which is the putting it into production and monitoring what it's happening and refreshing your data and refreshing your models and things like that. So
Yes.
yeah. So this is what we talk about when we talk about DevOps, and this is really programmer, developer focused, right?
Mm-hmm.
This is the union of people, process, and products to enable continuous delivery of value to our end users, right? And especially with predictive models, value is really clear. Like, what's the value of this predictive model? If it's being used in your application, you know the value. It's to predict things accurately, right? Mm-hmm. But this process of continuously delivering that value, you always want to be increasing the accuracy. You always want to be making these models perform better. And to do that, you need to refresh them.
Absolutely. And I love the continuous delivery piece of this statement, because a model is never 100% ready. Like it's never 100% perfect, and it's never going to be 100% accurate every single time, right? Like as your circumstances change, so say your customer base changes, or it's a new month out of the year, or a new day of the week, you might need to refresh your model in order to reflect those changes in it. The example I always like to give is if you were a Microsoft store in downtown Seattle and you were trying to predict how many Surface notebooks that you were going to be selling on a Monday, you're probably going to be selling a whole bunch more on the Monday of build than you would other Mondays randomly throughout the year. And if you didn't have the ability to incorporate those like spiky periods in your data set, or changes for holiday seasons, then you wouldn't have a representative model.
Yeah.
So, yeah.
And frankly, the more these models get used in real world scenarios, the more data you have and the more accurate you can make these models. You can build on them. Mm-hmm. So this is a continuous process. It's gathering new information, using that new information to improve the models and work a little bit better in the applications, like deliver the actual value. So that process is really important. So DevOps for data science is still kind of a pretty new area, right? So we talk about DevOps in software development a lot. And data scientists don't really start from the same point of you as developers.
Not even. So most data scientists aren't coming from the computer science background. Most of them are either statisticians. A lot of them are physical scientists, so either physics majors or mathematics majors. And there's not really a lot of understanding of software development lifecycle best practices. So version control is really difficult to explain to a person who's usually working in an isolated environment by themselves. Being able to implement tests, that's also a very hard concept to explain to a data scientist. So Damien, whenever he was telling me about this thing called VSTS,
Yep.
It was immediately apparent, like, oh, hey, it does these checks before certain builds are deployed, right? Or before you're able to push your model out or your application out into production. And that's precisely the same mentality that we should have for machine learning models.
Yeah. So we've kind of we've got to the point with software development where the way that we should be doing it is writing our code, having that in source control, and then have a pipeline, like a build process, some tests that run, a deployment to a test environment to run some more tests and make sure that everything works okay, and then promotions through to your production environment, and monitor what's happening all the way through, monitor how people are using that application in production and how effective it is and what parts need more work and so on, and feeding that back into your tooling. Mm-hmm. So these are things that align really well with this data science process, and like improving the models, testing the models, working out what things need to be fixed, what things need to change, and like iterating on this process.
Absolutely, and gathering the telemetry too is really, really cool. So as a data scientist, the thing I love the most is data, right? Like I love having the ability to input structured information into my models, and a lot of the time I don't have the data I need or the data I would like to have in order to build the best predictive model possible. If I'm able to talk to Damien or to the people who are developing the software and say, hey, it would be great if we tracked this particular button click or this particular mouse movement or this bit of user behavior, then it would really, really kind of add value to the thing that I'm creating. Mm. And just that partnership of working closely with the software team and making sure that both of us understand each other's needs is really, really important.
Yeah, we have very different fields, and I don't know what stuff you need.
Yeah.
And you know the process that you need, but maybe not the best tools to use it and
absolutely.
Things like that.
And so VSTS, though, I think is a great sort of meeting point between the two of us where we can see what tooling is available, all of the extensions to be able to support that process. And
yeah. So for those who don't know, Visual Studio Team Services, or VSTS, it's the DevOps solution that Microsoft has. If you were in the keynote in day one, you would have seen my boss talk about VSTS and go through the DevOps project and create a pipeline and all that sort of stuff. Ultimately, under the covers, the build, test infrastructure and the release infrastructure is a kind of the guys are all over there, so they're not going to hear me, but it's kind of a glorified task runner, right? There's all these things that you can run and tasks that you can implement to do the work for you. And from a data science perspective, we're having lots of conversations now about how to actually make this successful for data scientists without them needing to do too much work. But as a task runner, you can still run Python scripts. You can create models from TensorFlow things. You can tell that I don't know what I'm talking about. You can do some TensorFlow machine modeling process predictions.
And monitor the logging. Like that's the coolest bit to me, at least. Like being able to see what my model's performance accuracy looks like over time, or its F statistic, and then using that as a trigger for whether or not to retrain or to send an email to let me know that something is wrong.
Definitely.
Yeah.
Do you want to open up to some questions?
Yeah.
And things? We've got stuff we can show you and talk about, but it's a relatively new field, especially for me. DevOps for data science. So I kind of want to get feedback from other people, what stuff they want to know about this convergence of the two areas.
And I'd also like to give a plug too, if anybody is interested in reading a technical paper on this, there's something called TFX, TensorFlow Extended, that was kind of released in 2017, and it is absolutely phenomenal. It goes through the entire development lifecycle for machine learning models and how you would want to go about doing data checks, doing sort of accuracy and F statistic checks, and then also retraining your model and getting it into a, yep, there we go. It's an end-to-end machine learning lifecycle study. Thank you. Mm-hmm.
You're right. I can push buttons, okay. Mm-hmm. I think there was a question up there.
Yeah. Oh, GDPR compliance, right? Yep.
So, I mean, from the version control's point of view, I wouldn't necessarily consider the data itself to be something you needed to put in version control. You could put models based on the learnings from those data sets in version control, and the algorithms and all of the code that you write to make those models work in source control. And then as well as that, the artifacts, like the actual models themselves in a versioned repository of some kind, whether that be a Docker hub, if you're doing Docker containers, or package management systems to say, here's the version of the file that I have. But the data itself, you could still lock that down pretty much the way you are. It's just when you run the model training and things like that, that's when the algorithms would pull the data, use it, and then lock it away the way it was before.
And so there's also, and the question was about GDPR compliance and about whether it could be considered sensitive personal data to build a model on, say, someone's name, rank, serial number, address, all that good stuff. So there's actually been a startup in the last couple of years called, I want to say it's Ocean Protocol, but that might be, I want to say it's Ocean Protocol. But what it is it's using yet another buzzword. It's using blockchain to do versioning of data sets so that you can see precisely which names are added, which files are added, and be able to understand if there was ever some sort of legal issue where you would want to remove someone's name or someone's identity from a model, you would be able to trace back that data set to every single instantiation that it had in your application. So if you do want to get that granular, if it is ever a legal issue that you need to know every single model that leveraged that person's data and retrain it on not that person's data, then there are solutions that could help you with that.
Interesting.
Oh, I was right. I was right about the name. That's awesome.
You know, all I do is look up websites for you while you mention them.
No, you're doing awesome, Damien. And he has taught me so much about VSTS and about DevOps.
I still don't understand data science, but
I still don't understand DevOps really well, so it works out nicely.
Awesome.
Yep.
The other thing that I was going to show, and I'll be completely honest here, I haven't looked through this a great deal, but this is a Visual Studio Team Services, and these are build definitions for machine learning models, right? Mm-hmm. They will build predictive models. And you can see this TensorFlow stuff running on CPUs and GPUs. Have you looked into this in depth?
Not in depth,
okay.
but having the ability to define requirements for models, especially for the retraining bit, is huge.
Yep.
Yep.
So as an example, let's just have a look at one of these. I'm going to choose this one because it is parsing. So if we look at what it's doing, I mentioned that VSTS was basically a glorified task runner, which those guys would kill me for. So right up front, we're running on this on Windows. So this is a PowerShell script, but it's just calling a Python training .py or train.py. It's then publishing those artifacts back up to VSTS. And it looks like it's putting the logs in Azure Storage as well. So we're immediately getting the results of this training model to see how well we're performing and things like that. The bit in source control, though, is this training stuff. So if you look at the code, which is held inside VSTS, this is what we have. Where was it? It was in training, probably. Train.py. So this is the file that's in source control. So if this changes, if you update your model, or the algorithms you're using or something like that for the training, this stuff is versioned. You can come back and say, well, this version was actually performing much better. Let's roll back to there. Let's do a branch and try and work out how it performs with a different algorithm. Maybe let's do an entire new project and have this stuff traceable in source control.
Absolutely. And having the ability to publish logs directly to Azure, directly to whatever that location happens to be. If you're a data scientist or a machine learning engineer, you're obviously, or you're probably in love with TensorBoard if you've tried it out before. It's kind of a visual inspection tool for deep learning networks. And if you've got the logs in a place where you can just ping them, and immediately accessible, that means that you would be able to access it even though you're not necessarily the person manually running the model each time.
Yep.
Yep.
Yeah. So you can actually work in a team like this and have different responsibilities. Yeah. It's pretty cool. Any other questions? Yes.
Right. So the question was, how do you determine what would be a pass-fail for the model? An example would be as you retrain models, so as you refresh it with new data sources, if the accuracy of your model ever fell below a specific threshold, right? So if, say, your business requirement was that you needed to have at least 85% predictive accuracy, and then, after some sort of model retrain, you're suddenly down to 77%. That might be a trigger that you shouldn't deploy that model, the latest version, to the application. Or it could be any other metric that would give you some insight into the performance of the model itself. So F statistic it would be another. You could also say you could do a trigger on if there's any new additional data added, or if, say, the data that you had added initially had 4 different categories for one particular feature, and then another feature category had been added, so you suddenly add a 5th one. That would be a great trigger to, hey, you have a new kind of configuration, a new structure for the incoming data set. Take a look at it, because I guarantee you that if you don't take a look at it at this new sampling frequency or at this new data type, then your model's going to go kathunk. Like, it's not going to do well.
So those are triggers to refresh your model, right? Based on the data?
So the data bit would be a check to make sure that the incoming data is the same as the original data, and that would be a check on whether or not the model should rerun at all. And then the other one would be after the model's run and it has accuracy reported back and it's too low, that would be a check on not to deploy it.
Yep. So one of the things in VSTS as well is this release process. So I did the build process, which builds the models and gives you the logs. The release process right here, they're only going to one environment. But if we looked at like deploy model to Kubernetes, if we edited that one, oh, they've actually gone further than that. So deploying it to a test cluster, running some tests around it, and then deploy it to the prod cluster if it meets your requirements. You can even, and this is GA at build, we've got this feature called release gates, and they're actually enabled. That's amazing. There you go. Check output from A/B testing. So what happens is they deploy to a Kubernetes cluster, they run a whole, I wasn't actually expecting this, this is amazing. They run their testing on it and make sure that it's actually performing, and I'm guessing based on A/B testing, they're comparing it against the current production model.
Yep.
And if that response is, or if the accuracy is better, then it will automatically flow to the production environment. So this model, this process they have, means that you can just try things, update your code, update your models, and it will automatically flow through to production if that model performs better than the previous one. So as a data scientist, as somebody generating these models and doing all the work on the ground, they can just focus on their work, and the actual deployment of better and better models is kind of handled for you. This is just hitting an Azure function by the look of it. So
and it's awesome.
Yeah. So this is the deployment gates are GA at build. So they've gone live at build.
Yep.
I'm so glad he put that in there. That's amazing. Yeah.
Cool. Any more questions? Yep.
This is the batch.
The batch, yeah. So the question was around, can you use the, is it AI batch
the
So there's
Azure Batch.
There's Azure Batch AI.
Yep.
And that's, I think, leveraging Spark in order to spin up a cluster.
Okay. So I don't know the answer to this, but I'm going to find out right now. Does that have an API or an endpoint?
Yes. So it has the ability to, you can use the command line to trigger. So you can use AZTK to launch a Spark cluster.
Okay.
And then I am assuming that Batch AI also has a command line tool.
So
Shell scripts. Yeah.
if you can run it, the general rule with VSTS is if you can script it, you can do it. So you could either choose the path from your source repository, which is, this is how I call Azure Batch AI. Am I going to get that right? Azure Batch AI to do the work. And that is just part of the orchestration that VSTS does. So it will fire off that task, and then you could either put a task in here to wait until that was done, or have a trigger based on that completion to say, all right, now that's done, let's go to the next step. So again, with that pipeline that I was showing where you have the gates, that could literally be an API hit to say, is this done yet? And if it is, all right, let's go to the next environment, which is basically taking the results of that and pushing it onto the next environment. Yeah. So you can fire off that stuff absolutely from tasks inside VSTS. Out of the box, though, you're writing scripts. And this is the kind of stuff that we're talking about now, how to make this stuff more first-class citizen. So that's one that I'm putting in the backlog in my head, to be able to fire off Batch AI and wait for the response. Would that make sense as a build or release task? Yeah, so the environment in VSTS is poorly named. I'm glad there's nobody from the VSTS team here. Environments are really just a collection of tasks. So this environment has one phase, and there's 3 tasks, or 2 once I delete this one. So this is all that environment is. It's not necessarily a machine or a target or something like that. It's just, when I'm talking about the training model environment, that's just these tasks. The next environment could be, all right, that's finished now, what's the next thing I need to do? So part of that, part of the improvements we can make is looking at renaming environments to something else. We've had so many discussions about that, though.
Yeah. And the other thing that I'd like to highlight, too, and the Kubernetes, seeing Kubernetes reminded me, if you ever need to change sort of the hardware requirements based on your data set, so say you're doing a model retrain, and your startup has been wildly successful, and suddenly you no longer have 1,000 customers to train on, but you have 1 million, your Pokemon Go or something, then you can also use Kubernetes to say, all right, if we have less than this many customers, then you can use a CPU cluster, you can spin up Spark, you can do distributed machine learning there, or if we suddenly have massive customer requirements, crazy numbers, scale up automatically to GPU-enabled hardware, and you can use Kubeflow for that, and then also a couple of other tools. But Kubeflow is open source, and it's very good.
Cool. I just looked at the time as well.
Are we over?
Yeah, we're over by 2 minutes.
Sorry. Sorry for stealing y'all's time.
So I'm going to apologize as well. I need to really quickly run to Channel 9 to do something there.
Okay.
What are you doing?
I'm going to probably run to a podcast, but I can take a couple of questions if anybody still has them.
There's also the Twitter handles. That is absolutely the best way to get hold of me.
Absolutely. And the same here. Like if you tweet at me, it goes directly to my phone.
Cool. Otherwise, thank you very much.
Thank you.
Have a good rest of the build.
Yep.